Next up, Eric van der Vlist. It's an XQuery talk now, so please take it away.
Okay. Maybe a little bit bigger. Can maybe maximize those. Okay, so good afternoon. My name is Eric van der Vlist. I am an independent consultant. I like to learn new stuff. I used to try to relate new stuff to old stuff, and I like to share the result of this. My slide, paper, and everything is available at this address. I will give it later. I have taken a lot of risk for this presentation. Future will tell if it was wise or not. So, what is data-driven programming? A long time ago, I have discovered something called data-driven classes. It was in an open source convention in 2003. And the paper is still available on the web archive. You have the link here. So, and really, I was really impressed by this presentation. And this is extracted for the presentation itself. It says, data-driven technique minimizes the impact of new and changing data structure and APIs. And this is something which is really very important for us, I think. I think XML is not really about angle brackets. It's more about the way we see data at large can be documented as well. And the fact that the data is more important than the code is something which is important for XML. And it's really the basic of data-driven programming. And it has been a source of inspiration for me since then. I have written my own XML-driven classes in Python the year after the presentation, and then something for Java, which is called treebind. And so, again, it was a long time ago. So what are data-driven classes? I've said that they were cool. Now maybe I need to tell what they are. This is, again, extracted for this presentation. Say that all the classes are data-driven in some senses. And that data-driven classes are classes which are defined dynamically by the data themselves. So now, what is data-driven programming? Data-driven classes, of course, are very linked to object-oriented programming. And now with new languages such as XQuery, maybe it's not that new, but it's quite new for me, we are out of the scope of object-oriented programming, and we need to look at data-driven programming at large. And there are a number of different definitions on the web about data-driven programming. This is one which is taken from Wikipedia. In fact, just say that it's a paradigm in which the data is defining the step taken by the program rather than the program itself. And it goes some examples of languages which are, I would say, natively data-driven. Let's say that it's the case for SED and OG, for instance. In these languages, the data is really what is driven the program. It's not the other way around. And then there is a very old site, but which I find very interesting, which is called C.com. C.com is the ancestor of all wikis, I would say. And you have some good stuff in it. Say that, for instance, this one, that data-driven programs are programs in which process data files which contain code in the program to do different things. And you give an interesting example. The extreme case is an interpreter and the interpretable program files. And then I have found also a website which is called, I don't remember the page, Data-Oriented Design, which gives another definition, which is little bit the kind of complementary to what that we've done. It says that if the ultimate result of an application is data and all input can be represented by data, which is the case of a lot of applications we are developing, then it makes sense to use data-driven programming. Okay. I don't have enough time to spend too much time. So I will give now a few examples. The hello world, which everyone knows, of course, this is the hello world in Java. This hello world is 0% data-driven because it doesn't take any input. So whatever input you will give it, it will give the same result. On the contrary, the Java virtual machine, which is running this program, is 100% data-driven, or almost 100% data-driven. Because if you change the program, it will do a completely different execution. And the Java code is data for this, the JVM. So during the past years, I have been using a lot data-driven, and these are two examples which I am using on a daily basis, I would say. So the backup utility, which I use for all my servers and machines, is using the Python framework I have developed in 2004. And this is a definition of a backup, for instance. There is a task here, and say that it must save a Postgres database, MySQL database, and then it must duplicate this directory on another server. So this is an example of data-driven programming. The program that executes this is data-driven, and it's using data-driven classes. Another example is the list manager, which is powering the XML guild. It's powered by Tribang, so the data-driven sources I have developed for Java. And the XML elements are mapped to classes, methods, that wrap actions. And we can briefly have a look if you want. So let's go. So you see that it's very close to what the program needs to do. Data is very close to what, so there is a root element, for instance, and then it tells that the server is on this address, the store type is IMAP, user, password, and so on. Then that I want to manage a folder. The folder name of the folder is inbox. So the program which will read this will periodically look at this folder with all this information. If a new message arrives, it checks that if the recipient is either one of them, and then if it's the case, it will send to the list. And this is directly mapped to a Java method by the the data-oriented classes. And so, in fact, if data-driven programming looks familiar for us, it's probably that in XSLT, all the transformation we are doing are data-driven programming, in fact. Each time you write a template with a match clause, you are natively binding a set of data instruction to nodes in an input document. And basically, that's in Wikipedia, they mention awk and sed. And obviously, XSLT is another very data-driven programming language. Now we have functional programming, and XQuery introduced the XML word to the world of functional programming. And I have not found anything about data-driven programming in using functional programming languages. That being said, we still need to do data-driven programming in a functional language. We need to be able to map a function to nodes in a document. So, and really, the way we will do it is really the topic of this talk. So now, functional XQuery. In fact, I will be doing an example based on that XML document. It's Angman game, and this, as explained as presented in Wikipedia. And so we will be processing over and over an Angman document, which looks like this one. So you have a world with different letters. For each letter, I have an attribute saying that it has already been guessed or not. And then I have the display. I can display the head, body, right arm, and so on. Okay. So to give you an idea of how that works, I will start by showing how it would work in Python with, again, these XML data-driven classes I have written. In fact, for each guess, I would define a method, and the method here is applied to the class, which is called letter, and the class letter will be bound to the letter element in the XML document by this instruction. And basically, if the value is if the value of the letter is the guess, then the attribute becomes true, otherwise it's false. And well, we can, to make it maybe more concrete, here is how it works. You have the initial document, and then for this letter, these become true, and I don't show anything more. If I do a mistake, this is still, there is no difference in the word here, but the display now is displaying the head. So in XSLT, it would be very easy to implement this. This is the same implementation for the letter. The letter would be updated here, and if the guessed attribute is equal to the current guess, then it would become true. And if I don't define any other template, it wouldn't change if the guess attribute is not the current guess. So this would be the implementation, basically the same of what we've seen in Python. It would be the implementation in XQuery. So now, how would you do this in XQuery? One way to do so is to use a library that had been presented by John Snelson in XML Prague, I think it was 3 years ago. I must admit that when he presented it, I have lost most of the concept. It was so new for me. It's called transform.xq. It's available on GitHub. You have the link both in this paper and in the paper and on my presentation. And basically what transform.xq does is that it allows you to define things which looks like XSLT transformation in XQuery. So with transform.xq, the equivalent of the XSLT pattern for the guess would be this one. So it's defining a rule, TFM rule. The rule associates basically a pattern here, letter. It's a letter element with a guessed attribute. No, sorry, it's the guessed attribute of the letter element rather than that. And then this pattern is associated with a function. And the function is doing what the XSLT template would do. In fact, it's not exactly the same because in fact, you don't have the possibility in XQuery, in standard XQuery, you cannot do dynamic evaluation. So what John did is that he generated a parser for the match patterns here, and this pattern has only a subset of the XSLT patterns. So for this reason, here I am not able to add a condition like I did in XSLT. So, yes. And so this is the way in which transform.xq is associating a pattern and a function. And this is really what I mentioned when I said that in XQuery we needed a way to associate instruction to nodes in a document. And well, we can have a look. Yeah. For whatever reason, this doesn't work in Saxon, it returns an error. I need to dig a little bit in the code to see what's happening, because I think the library is too complex to submit it directly as a bug. But it's working in MarkLogic. Here, you submitted it in MarkLogic, and you can see that if I don't know why, but MarkLogic doesn't indent the result. But, so this is the result of my information, and you see that it's touching. So there is another way to associate a rule to associate a template to a node in transform.xq, and it's done during annotation. But this one relies on the MarkLogic extension. But this would be equivalent in using transform.xq as the preceding one, except that it's less portable, of course, because it would run only on MarkLogic, this one. Now, so what does transform.xq bring us? It gives us a parser for a subset of XSLT match patterns, which is a kind of convenience to write an expression, a test for binding a function to a node in the document. So, and it gives us a way to find XQuery function, which basically plays the role of XSLT templates to match pattern. But transform.xq, on the other hand, is a very complex library. So I've also wanted to try to see what we can do without transform.xq. And in fact, if you want to step down and forget about higher order function, because transform.xq is using a lot of higher order functions, you can also wonder what you could do without this function. One way to do it would be to use a recursive function and just a bunch of if-then-else. This is the piece of code which is equivalent to our template for the guess attribute, if in that case. And I was really surprised to see that it's very readable, in fact. The whole transformation in XQuery is something like this. So I have this transformation. I give it node as an input parameter. It returns node as well. And I test if the node is the root element, then I do that. If the node is an instance of attribute, I do. This is a snippet I have just shown in the previous slide. If the node is an instance of the attribute shown, I do that. Otherwise, I just copy the. So you see that's, well, it's not very trendy.
Using type switch there.
Sorry?
Is there any reason you're not using type switch there?
No, just wanted to do something as simple as possible. Just, yeah. And when I wrote this function, I was really surprised to see how simple this was. I wanted to present something about higher function, but well, I think this can work in most cases. Yeah? And of course, it produces the same result. This one works well in Saxon. If I run it, I get the new version of the Hangman. Yeah. So now, using higher function, we can do something like this, in fact. I have defined this is a function which is not part of library anymore. It's defined in the XQuery file. And now I can also define my rule. I don't have the ability to use a match pattern there, but a rule can be composed of two different functions. The first function which will test if the node is matching or not, and another function which is what we need to do. So this is again the equivalent of the template for the guess attribute. The first function is checking that this is a node attribute, and the second function is copying the node unless this is a guess, in which case it becomes true. Yeah. And One of the issues we have here is that I am using XQuery 3.0. We don't have the notion of map, so I need to mimic a map. And to do so, in fact, I have borrowed a trick from transform.xq. I define a function. This is my rule function. But this function is returning a function itself. And the function is checking the key parameter. So it's kind of implementing a very simple custom map. If the key is predicate, then I return the predicate, the first function, which is testing if a node is matched or not. And if the key is action, I return the action. So this is kind of a workaround because we don't have map in XQuery 3. And then the higher order function magic is here. So it's really very simple. It's just reading a transformation, which is a set, a sequence of rules, and it executes the first action which matches. So it's less complex than the priority matching we may have in XSLT. It's more similar to the priority of rules in a schema to schema, for instance. And then transformation itself is this one. I have a set of rules, a sequence of rules here. So it's, I think, slightly more verbal than the sequence of if then else, but still quite readable, I think. So within this, because we don't have map, we simulate them. Within this as well. Okay. So my conclusion with this small experience is that higher order functions do facilitate data-driven programming in XQuery. Of course, I have shown how they can be applied to a transformation, but the function which is called when a template is matched could be anything. It could be I don't know, an XQuery update, for instance, to go to update a database. It could be pretty much anything. I think it's really interesting to be able to declare the action to take matching node in a document. It's something which is very powerful in XSLT, and see that it's easy to do in XQuery, either using just if then else of type switch, or using this kind of thing. Maps are missed in XQuery 3, but you can simulate them easily. Transform.xq is really very powerful, but again, it doesn't work in Saxon. I don't know why yet. And if you use them, you will have a transformation or an XQuery which will be more concise than what we've seen. And again, good old if then else is not as boastful after all. And that's all. I want to thank all the people who have reviewed my presentation. John Snelson for Transform.xq, George Bina for this tool, and XML London.
Michael, yes.
Yep.
Thinking about the title of your talk, Data-Driven Programming, you've written some XQuery code that seems quite repetitive.
Which one?
The list of rules. It sort of struck me that you could turn that into data with some XML that had the patterns and the actions.
Yes.
And generate the XQuery from that.
Of course, yeah.
I do know another XML-based language that has rules and actions, but you could invent your own, and I've often done it myself. Why write the XQuery when you could write that as data?
I wanted to see what we can do in XQuery. That was my original goal. And I wanted to see what higher order function, especially in XQuery, could help us to enable us to do. Just nothing else.
But nice anyway.
Yeah.
Did you consider simulating maps with John's other neat thing, the red black tree? notation?
No, in fact, wanted something simple. You see, this is just a few lines.
You can simulate maps quite easily in XQuery 3.0.
Yeah.
Using the red light tree.
But I wanted the second set of XQuery to contrast with the first one by not using any library and just exposing the basis of what's.
Okay,
Thank you.
Thank you, Eric.